So this week, we're going to do Chapter 7, Motion Study, the Workstation Design. So the Workstation Design is just a drawing, and we normally do the top view of the workstation, and we include the equipment, material, operator, space. When we use the principles of motion economy, what we do is we apply that principle to the workstation design. And what we expect is by doing that, we're expecting the most efficient motion pattern, okay? Because if you don't have efficient motion pattern, you wouldn't be able to get the production as smooth as possible. So you can start your design anywhere you want to start. And we draw the layout by using, we include the work table and then incoming materials like bolt, clamps, washer, nuts, packaging quantity, etc. And outgoing materials as your finished product. And we have our operator space and access to the equipment, location of waste and rejects. We have fixture and tools, and you definitely want to make sure you use the correct scale for your drawing. So this is what workstation layout looks like. This just is showing you the muffler clamp assembly, and here is your layout, and this is your workstation, and we're literally drawing the layout for this workstation. You can see he's got U-bolt, nut and washer, bracket, and then here is your operator station, and he's gonna take his output on both sides, and he's got a waste on this side, and again your scrap here. And here, this is the scale of this workstation. Okay, so this workstation design layout, you can see a bit of the motion pattern right there. It is showing you the operation, machine operation. So you have your operator and the machine, and here is your conveyor going, and your equipment can be the machine or jocks or fixture, and is basically added to the drawing. The principles of motion economy is nothing but they're just guidelines. So the guidelines for efficient and effective workstation design. And we call that principles of motion economy. So efficiency is nothing but doing the things right in job. Effectiveness is doing the right things in job. So therefore efficiency and effectiveness together, they mean doing right things right. So therefore don't do a job that's not necessary, and don't do a useless job efficient, especially in the industry. Now we usually design a workstation to promote mirror image motion patterns. So what we're trying to do is for the hand motion to operate the hands as mirror images. So when you take a look at it here you have your normal reach versus the maximum reach. So this side is your normal reach, and here on this side is maximum reach, and here is your normal reach. So when hands are reaching for two parts at the same time, what we want in the workstation is we want the bins to be placed at the same distance from the center line. And also you gotta make sure these reaches gonna be as short as possible. And both hands of the operator or crew, they must be working by doing two parts at a time to save time anyway. And human hand is actually the most expensive fixture. Therefore, you should use the best out of it. So we have three distinct motion types. Well, they're just the basic motion types. So ballistic motion is nothing but you're putting one set of your muscles in motion, and you're not trying to end those motions by using other muscles. So for example, throwing a part in a tub and hitting a panic button on a machine is an example of ballistic motion. Another one is your controlled or restricted motions, and this type of motion requires control at the end of the motion, so it considers safety and quality. Okay, so that's for controlled and restricted motions. Again, safety and quality. So for example, you can see this type of motion placing parts very carefully. Continuous motion is nothing but it's usually curved, and these motions are pretty natural. So when a body must change direction or speed is reduced, or two separate motions results. So these are called continuous motions. For example, reaching to a box of parts, laying flat on the table. So one's motion to the lip of the box, another motion is down into the box. So these are all continuous motions. So at the workstation, when you think about the location of parts and tools, we want to place them at a fixed station for everything, okay? And we want to have everything as close as possible to the point of use. So for example, hang the tools from counterbalances over the workstation. So this tool is as close to the point of use, and it is totally fixed at a place at your workstation. Okay, that's the way we want to put the parts and the tools. And we usually design the fixtures and jocks to hold parts to release the hands for more useful work. So for example, you can look in this picture, you can see the conveyors can move parts past the operator, so they don't have to get or put aside the base units, okay? So here is the same thing. We try to design a workstation to make sure that the operator can release the hands of as much work as possible. The next thing is, as much as you can, you're going to use gravity because it's free and you can move parts closer. You can also spare production expense by using gravity. For example, when you look at this example, gravity is moving parts closer to the point of use. So you can see this box with a slope, and it's totally designed to use the gravity to slide parts down to the front of the box, okay? Ergonomics is human factors, and it's a huge thing in workstation design. These are called operator considerations. So they all come, your crew or your employees or the labor come in various sizes and shapes. So they must be allowed to work at the right height with comfortable chairs and enough lights and adequate space to perform their task. So what do? We design each opening so that the largest person may fit through it. We design a workstation for each surface height so that the smallest person may reach it. We also design the workstation so that the weakest can perform the work. We design the workstation so the strongest will not overcome. We also provide easy adjustment for the range of sizes and provide independent adjustment for each human dimension. And the last thing is we provide for alternate postures during the work period. So these are all consideration for your human factors. So when we think about the work surface, we gotta make sure the work height is not going to create any kind of issue for the operator. Okay, here when you look at it, it's kind of low, so it's a wrong walk height for him. So you gotta come up with a proper work height in your design. So that way the operator is going to produce less fatigue, so he can work continuously. So make sure you design the workstation for sitting and standing, but you have to also keep work height constant. Okay, constant and proper work height, so important. Also, the work surface platform must be sturdy, safe, and large enough to comfortably work on it. Another consideration at your workstation design is seating. It's so important. The seat of a chair is most comfortable when the forces of the cushion are equal on a human hip. Okay, so this area is so important. So requirements for the ergonomic comfort chair. So they must have appropriate contour and a firm cushion. They must have ability to tip forward and to lift. So hip must be higher than the knees. And they must have adjustable back for the height and angle of the spine. They must have adjustable head and neck support. They must have a lumbar cushion that is adjustable for the curve of the spine, and kind of like this here. And they must also have appropriate arm and wrist rests designed for the joints. And finally, they must have appropriate base and wheel system for the work location and job. So comfortable seats must be provided. To why is it so important is to reduce your work stress. Okay. So for space allocation at your workstation, we follow 3 feet by 3 feet. So that's your standard operator space. If two operators are back to back, use 5 feet, okay, between the stations. So here we have 2 robots here, so that's 5 feet. Then here side to side, so we're going 3 by 3, okay. So with large fixtures and complex machines, we're going to add more space to set up and repair. The next thing is your climate of your plant must be conditioned, okay, for health and also well-being of the employees. You don't want to work in an environment that is so stuffy or lack of air, and so you got to make sure that the environment is healthy, okay, because unhealthy environment is going to result in personal, civil, criminal liability and also liability of the company. So it's a pretty dangerous thing to make sure the environment is good for everybody to work comfortably. The environmental conditions to be considered include illumination, vibration, noise, climate, toxicology, and safety. So for illumination, the standard for industrial work, we're looking at 500 lux overall. So the light must be positioned properly according to the job. Why? Because insufficient light is going to cause eye muscle fatigue, okay, bloodshot eyes and headaches. We don't want anybody to suffer that. So we're going to set the environment with the right illumination for the job. Vibration, I've told you about this because we're always subjected to vibration. But in industry, the vibration we're talking about comes from your tools, large machines running all the time, and trucks, transportation vehicles. So you will be getting all the vibration from these sources. And it can be reduced by redesigning, okay, the vibration sources or isolation of the operators from the source by using insulating materials on handles or soft floor mats and cushion on chairs. The next thing so important is your noise, and this is one thing that is going to get to you in the industrial environment because it's a very common source of annoyance. And noise, and also we can kill it 100%. So noise is going to affect employees in many ways, like it will degrade task performance, distract or annoy nearby persons, interfere with communication, or also contribute to temporary or permanent hearing loss. And this is what I get. Anyway, so noise management planning work on reducing noise by placing a barrier to reduce transmission through air or other materials, like absorbing the reflected or captured noise, or reducing the volume or spectrum of the noise generator. Okay, so we use this kind of barrier for the workstation in order to reduce noise. The next dangerous thing is your surfaces, cold or hot. So you'll definitely see often those kind of signs or notice for hot, cold surface. interior surfaces of the chamber can cause burns or frostbite. And you have warning like burn hazard, hot surface inside, allowed to cool before servicing. Okay, so hot and cold surfaces are not safe. They're not safe for all employees. And cold surfaces can tear and damages the bare skin. Hot surfaces can burn your bare skin. So therefore, we gotta make sure the temperature range to be between 66 to 76 degrees Fahrenheit, and that's your comfortable temperature range. Humidity, we want set it 70 to 20%. Airflow, we want to set it 40 feet per minute, okay, in the manufacturing environment. Why it's so important? It's because human skills start to decrease at 60 degrees Fahrenheit. And that is like reaching a reduction of 20% at 45 degrees Fahrenheit. So therefore, make sure you set a comfortable temperature between 66 to 76 degrees Fahrenheit. Okay. This table is just showing you your heat discomfort reduction. So reduce the temperature, air conditioning, so that's the quickest but often most expensive approach, and you can read through that. So many different ways to make sure you are comfortable, okay, with your heat settings. And here is your work practices for protection against heat illness. One is you use your radiant heat protective clothing, and you'll definitely see this type of clothing in nuclear power plant. Next thing is on the job, buddy system, work and rest task, flexibility scheduling. You can do provision of tablets, that means not cold, drinking water. You can do scheduling tasks in cooler hours of the day. You can train the workers in heat illness first aid so they know what to do. And the workstation must be perceived as comfortable, simple, and safe. Alright, the last thing is our motion patterns. Again, it's so important to create a very fast and quick production line, and this motion pattern is so important in your workstation design. So the motion pattern is the path taken by both hands in the process of making one part or pair of parts. So the path for each hand must be totally unbroken, and it must be totally in a complete loop. Okay, so it's a blueprint of your work method, and it's also a bill of material for time standard. So here you can see the workstation and motion pattern for this little pin board. Okay, a complete loop right here, and it's definitely not broken. So this is our last example in this lecture, and here is shown a simple motion pattern for the cable clamp, and you can see all the loops here. So basically what's important is the path taken by both hands. So here you can see all the unbroken and complete loops. Why motion pattern is so important? It's to get your time standard correctly. If you get that, you can be able to design your workstation properly and support a very smooth production line. Okay. Alright, that's it for chapter 7.